Hello, everyone. Welcome to FHE on Chain podcast. Today, my guest is Xiang from Primus. He is the CEO of Primus, and he's a cryptographer with a lot of influential papers in both ZK and FHE fields in cryptography. I'm Furkan from FHE on Chain. I'm working as a researcher and technical writer at Inco. And today we will chat about mostly Primus, FHE, ZKFHE, and the other privacy enhancing solutions. So yeah, first of all, Zhang, thank you for being with us today, and we would love to hear your background in the industry.
Yeah, thank you, Furkan, for having me. So yeah, my name is Sean from Primus. Yeah, and basically my background is cryptography. So actually, the interesting stuff is that I started my PhD back to 20, 2009, which I think that's that time that FHE begins, or just Greg Gentry got the Holy Grail. So at that time, I started to do the research on cryptography, and my research focus is also FHE. So it's a very long time ago. So yeah, after that, I actually joined the industry. Like I was a chief scientist in Asia Pacific startup, like focus on help them to build a privacy preserving like technologies. Build the teams from scratch and coding, software, hardware, everything about cryptography. So then I joined O1 Labs and as a cryptography engineer for like 1 year. I helped them to also build these privacy preserving solutions. And after that, we studied the primers. So yeah, the reason we study primers is that we always think about, how we can leverage cryptography to serve or to help us to, to build a impact useful products to help them to build new applications. And the most thing that we are now focusing on this the entire life cycle of data. So we think that data is something lacking in Web3 in blockchain. We have very few data in blockchain. So we always think about how we can bring this data to Web3 and how we use that data. So that's the motivation of primers. So we actually build like two cryptography tools. The first one is DKTLS. So I think it's all about MPC and zero-knowledge proof systems, which means that we can bring like existing Web2 data to Web3 using cryptography, which means that we can verify that this data is correct. This is the first step. And the second step is that we are now working on ZKFHE or FHE steps. The reason is that after we always think that ZKTLS is always the first step because it only brings data. So the next step is that we have to compute the data. So once you handle like personal data, privacy is it's always a problem, is an issue. So we have to do something like using privacy preserving or privacy enhancing technology to do the computation without seeing the data, but still we can use that. So that's the main reason that we want to use FHE stuff, and that's my field. So it's quite exciting, and yeah, when we looking at FHE, we thought that there's always kind of missing part or big missing part is that FHE is something that we can outsourcing the computation to a third party that he can do the computation on the ciphertext without seeing the plaintext and return the ciphertext. So there's a missing part is that we have to trust the third party, the operator, because it's the definition of FHE. We cannot do anything with FHE to reduce distrust. So that's so we begin to okay, can we design this ZKFHE stuff? Means that we can prove you enable the operator to prove that okay, all the operations is correct. It's not something that he's cheating. So like almost like 4 years ago, I started to research this topic, but we have very few progress. And like 1 year ago, I talked to some kind of talented students. Okay, they came up with new ideas, and we design this protocol, implement everything, and the result is quite good. We kind of we can speed up to like 400 times than existing solutions, which I think we paved the road for the practice of ZKFHE. But yeah, it's only a start point. It's only a start. So yeah, we still need to put a lot of resources to this area.
Thank you so much. So like when like okay, you mentioned about several things which I really wanted to talk about. So first of all, like I came across a new like I mean I'm not sure if it's new, but like it was new to me at least. A like a keyword called MPC TLS. And like these days we've been, getting more familiar with ZKTLS, but like
Yeah.
I think MPCTLS is not, that familiar, like or like that popular, like across the industry and like the people in the space. So I would love to hear a quick intro to what MPCTLS is and how it differs from the other alternative solutions, basically.
So I have to say, ZKTLS is more like a market language. It's not, from their cryptography, terms. So basically, we are using two modes. So first of all is what we call MPCTLS. So it's all about MPC, but still use ZK. So it means that you need to do like a two-party computation between the client and a tester, and to do something very complicated stuff. And this is some startup using MPC TLS as their solution, but they always call it ZKTLS. So I just call it ZKTLS, but we still like use MPC TLS. So the other way is that they are using like a proxy model. It's kind of trade-off between security and performance. But yeah, the trade-off is acceptable in some cases. So it's more fast. And what we are now trying is that we actually started this project back to 2022. So there is an original paper called DACO. So when we see that paper, so we found that okay, it's quite heavy. We have to improve it to make it deployable in our product. So our cryptography team, so we have very strong cryptography, like 4 to 5 cryptographers professors in our team. That okay, we can design or improve everything. So after like half a year, we like improve like 10 times faster, and it's much more lightweight. It's still MPC stuff, but the core is that we are using like very lightweight interactive technology proof systems, because in this case we can use interactive technology proof systems, and we can make it much more lightweight. So, and I think the protocol is called Quicksilver. It's invented by our cryptographer. So I think it's always the go-to solution, and other like MPC TLS solutions want to shift to us. So I'm very happy, and I'm very happy to have them to build this. So yeah, this is always it's always about MPC and interactive technology proofs, and still MPC. But yeah, the people in the market only knows ZK stuff. So the market people just name it as ZKTLS. So I think it's different, but yeah, the same thing.
I see. Thank you. So okay, let's get back to like the verifiable FHE stuff. Yeah, like
Yeah.
I like personally tried to implement something around proving a BFV addition using Plunky 2 on my local, but of course like this is it was a toy example, because like it was like never efficient to use in a daily life solutions. But like you guys proposed a less than 10 seconds proof of bootstrapping in TFHE. So I would love to hear more like details on that. What the difference you bring with was, and then how it differed from the other existing solutions, even though they're quite like a few. But still, it was a really good improvement in terms of the benchmark you presented in Bangkok. So I would love to hear that like story from you directly, and then maybe we can discuss further on that.
Yeah, for sure. Actually, yeah, we have like two reasons to choose the FHE instead of others like BFV or BGV stuffs. So first of all, the starting point I want to do ZKFHE or verifiable FHE is that like back to 2 years ago, we published a paper called ZKCNN, which means that they can prove large language AI model or machine learning models with technology proof system. And the core part in that paper is how to prove NTT. entity or FFT. FFT is the core part in FHE. So at that time, I starting to think, okay, can we move this, technique to, to prove FHE stuffs? And at the very beginning, we are choosing BFV, but, it's very hard because using RNS, it has a lot of fields. It's not compatible with this kind of ZK snark schemes. So I spent like 2 months to think about it, but it does not work, maybe. So this is the first step. It is from the technical reason, and from the a production reason or the user side is that okay. So I think for now there's a very few developers know how to use FHE steps because you have a lot of parameters and you even have to set the depths when you're using BFV or BGV steps. I don't think normal developers know how to do that. So it's very hard for them to do. And yeah, sometimes BFV is fast than TFHE, but TFHE stuff has a very good advantage is that it's fully homomorphic. It means that you don't need to set up the parameter, but yeah, you need to, but you just set up once and then you can do everything. So this is the from the user side. So okay, maybe it's good choice to to work with TFHE steps, and it's very compatible with our technique in ZKCN because it only need to involve in like one field, which is very nice for us. So okay, and we just open the door. We think okay, that we can do much better. So then we choose the most difficult part, bootstrapping. So and we think okay, we have a lot of new idea that we can make bootstrapping like to prove bootstrapping very cheap, which is less than 10 seconds, more maybe 3 seconds in M4. So yeah, that's but this yeah, I have to thank to my co-authors. They are very talented people and the students. They came up with new ideas to improve the performance by a lot. So but yeah, we think that we actually opened the door to make the verifiable FHE really practical, and I was thinking about okay, we actually take more than 4 years to finish this job. But yeah, I think it's good one, and we're gonna make this paper public very soon. And I think maybe more people or research or cryptographer gonna to improve it further. Or we're very happy to do that, and we're very happy to share the result to to really promote this area direction to I think it's quite exciting in this area, right?
Yeah, it was really impressive and still really impressive. But like I had a question mark when I saw that benchmark. Okay, because like you also mentioned and like specified on the presentation that that benchmark was on like a single bootstrapping proof, but like especially in like programmable bootstrapping, like in TFHE, like bootstrapping takes place like almost any time throughout the processes, and then when especially we consider a user flow in a like decentralized or like even centralized TFA like FHE app, so there will be many bootstrappings. I'm wondering, how this benchmark like changes when we increase the number of bootstrappings.
Yeah, that's a very good question, but I think, but yeah, the reason that we only do one bootstrapping is because the implementation is quite complicated. There's a lot of FHE, there's a lot of ZK stuff. You have to make it compatible. So we spend a lot of time to do it. So we only focus on the very simple case. And yeah, you are correct. So when we're using like to do like one comparison, you need a lot of like bootstrapping functional or programmable bootstrapping. So if we just scale to many bootstrappings, I think the performance will be it will not that good because the circuits is much larger. So we actually are working on it to see how to further improve and to to prove more than one bootstrapping, probably using recursive proof systems. So that's our next step. But yeah, I cannot give you an exact number, but we do have some ideas to improve that. And I also think that maybe sometimes we need like hardware acceleration to do that. And probably when you're kind of you kind of to support not very complicated applications. We can prove them in some reasonable time, and it should be much better than like maybe in FHE such as things like FHE rollup stuffs, or confidential smart contracts. If they are only like very simple operations, then we can speed up using verifiable FHE to improve the TPS maybe. So I don't know the exact number, to be honest, but I think it's quite a bright direction we can explore, and our team is looking into this area.
Yeah, thank you. Like with a for just a personal curiosity. So like apart from all these academic works, like your previous work on ZKFHE, like or this bootstrapping proof work, Premise also as a product, right? Is a product, a company that having a FHE product basically. So I would love to learn about the like protocol architecture of Premise, like what is the main product of Premise, and like what kind of use cases it enables. So and please feel free to dive into details as well.
Okay, so yeah, we're actually choosing different ways from other like FHE players in the market. So we kind of build this privacy preserving computation network. Means that in this network that anyone with computation resources can join the network, and they can provide this FHE computation service for any tasks that from the user side. And this should be interesting because I think we actually built some simple products like data sharing use FHE, but is HE is not FHE because we want to make it usable for these very complicated cases. So we are using like linear homomorphic encryption and using ZK linear homomorphic encryption to make it work. And but the whole roadmap or the whole vision of this network is that we can provide this general purpose FHE computation network for all these privacy preserving applications in Web 2 or in Web 3. So there's two reasons. There's two things we need to do. The first of all is it actually need verifiable FH because it is all about incentivize the computation resource providers to join the network. So you have to measure how much work you have done and get the incentives. So that's why we need ZK verifiable FHE to make it doable. And the other part is, we are not doing it, is FH compiler. So as I said before, it's very hard for the developer to deploy machine learning use cases using FHE. I cannot expect them to write machine learning with FHE APIs, low-level API. It is very, very complicated. Even me, I maybe spend 1 or 2 months to implement that. It's very complicated. So we are now doing a FHE compiler for machine learning models, which means that you only need the developers only need to write Python, or you can just bring the old existing Python code and put it in our compiler. Then our compiler can automatically compile it to FH operations. So just bring your code, then you can compile this. So we actually finished the design, and we have some compiler engineer in-house. So probably in the middle of this year, we're gonna publish our first version to enable the developers or even AI developers to use it. So yeah, the underlying protocol we're now using ZKS because it's more machine learning compatible, and there is a lot of existing work, solutions we can apply. So I think this is quite important. So we are not we actually have a TFH library in house, but we don't want to implement ZKS from scratch because I think there's a lot of very efficient ZKS libraries can use like OpenFHE stuff or C++ work, but it's okay for us. And we kind of deploy this solution with Python or other high level languages for the developers to use. So I think it's quite important to enable the builders or users to onboard our product very quickly. They don't need to understand all these complicated FHE stuffs, which I think is kind of very, 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 very hard to understand.
Yeah, so like main product or like one of the products is this compiler. I like if I understood it correctly, like just to understand like both the motivation and also like the model, like the business model better. So like you have the compiler, people can come up with their algorithms or like their codes written in Python or any other high level language, and like your like Premise compiler converts it into its FHE equivalent. And then like
Yeah.
people will be able to run their algorithm on encrypted data as well. But like just to understand from the business perspective, I'm wondering like, is this a centralized product or like a blockchain? Is it a blockchain product or can it be converted into a blockchain product in a decentralized manner? And like so this is one hand, and in other hand, I'm wondering like like of course I'm sure you have some data on that, but if it's like not internal, I'm wondering what is the like some sort of benchmark data, and like what kind of algorithms you tested the current compiler. Like I mean, of course I'm not expecting to run really complicated machine learning algorithms, but like maybe you could give some examples on, okay, our compiler works on this algorithm and like it works quite well to be used in daily lives.
Yeah, that's a very good question. So first of all, our product is so the strategy of Primus to do the product is that we actually we always is the user first or product first, to make it usable first, and then we gradually to make it decentralized. So that's always the strategy of Primus. We don't want to build a network but no one use it. This is not the goal of us. So everything like ZKTLS or IFHE, we go to the user, customer first. Okay, you can use it. The first step is that maybe we can do it in a centralized way, but we can make it more decentralized in the future. So that's always the strategy. And this is also like why we the same way we are building these compiler stuffs. And so why we do the compiler is that like 3 years ago I actually built something similar. It's actually MPC compiler or IZK compiler, which means that I can compile TensorFlow codes to MPC or general multiple systems, IZK systems, and anyone can. It's very like this. So anyone can just use existing TensorFlow codes, and then it's all good. So at that time we actually tested like complicated machine learning model like ResNet, maybe like 18, like sorry, it's 20, ResNet 20 or ResNet 50. So in our benchmark, I think we now can do like ResNet 20 in sec. No, it's not. It's maybe in less than 1 minute. Maybe when we finish our optimization, or maybe we can apply GPU steps to it. So somehow is acceptable, because I think we are not doing not latency sensitive applications. So it's kind of okay for us to like take like 1 minute or several minutes. We finish all the inference of this complicated machine learning model. So, but yeah, I had to say it's kind of we still need a lot of resources to speed up everything, like in terms of the algorithm part, or in terms of hardware acceleration part. So yeah, we are actually looking for collaborations on this part, because we don't want to. Yeah, we are not very good at building these GPU stuffs. So it's kind of very even like FFH stuff is very complicated. So we are good at algorithm part. So at the very beginning, we probably run it in software SPU, and maybe we can extend to like GPU. So that's our strategy for now.
Yeah, thank you. So like at the end of the day, it will be possible, but like let's say for me to build a salary payroll, software, and like bring it to your compiler and get the confidential version of it, right? Like, or like
Yeah.
something like that. Yeah. So like, is this a B2B solution, like in terms of business perspective?
um it's actually a B2B2C business,
Oh yeah,
I
yeah,
think.
sure, sure, sure.
So yeah, we don't want to, we don't want to do pure B2B because it's very hard, and I don't think it's a very good business model for small startups like us. And yeah, we actually our customer, maybe we want to collaborate with our customer, which is kind of other project, but the main goal is that we want to serve his clients or end users. So we kind of doing this B2B2C business, and it's more suitable for us, and maybe it's more suitable for this whole network. Maybe it's not a blockchain, but it's network. It's actually blockchain agnostic, but I think is a much better business for us.
One other thing I'm wondering is like, is it like the your verifiability solution like already implemented into this product, or will be implemented in the future when like when it becomes more efficient? So like at the end of the day, Premise product will be verifiable, or is it verifiable already, or like it's say it's one of the plans.
So yeah, it's always about the verifiability and the computation. So for data source, we are already verified by using ZKFHE. So everything is verified there. And of FHE, we are not, finish everything because, as you said, we can only prove one bootstrapping, but it's not, sufficient for the whole solution. So we are now improving it, and probably we got some intermediate solutions to make the product around, but eventually we're gonna deploy the verified battery to our network, and this is our I think this is our final goal to make everything verifiable and in terms of the source of data and in terms of the computation of the data.
Yeah, I think it's fair enough because no, I mean people even say like FHE is a baby, which is actually not that wrong. Like when we consider FHE as a baby, like the verifiable FHE might not be even born. So yeah, it's fair enough. But like I just wondered the vision. So like, and it's good to hear like you have the verifiability vision, and you will implement it soon. Like I mean, at least once it will be applicable enough. So like, I'm also I'm asking this question to other guests as well. So FHE, MPC, like these or ZK, these are both like privacy solutions, and like both in Web3 or in Web2, but especially in Web3. So do you see like a big interest in privacy from the people in Web3 or Web2? Because like I sometimes feel that okay, they're building something, you're building something, some other people building something, but like it looks like people not demanding for it, at least for now. So do you think it will change, or like like what, or like let me ask you in a more concrete way, what do we need for the mass adoption of privacy, and like what should happen for the two people to like to actually demand privacy for their products?
That's actually a very, very good question. So we actually think about it for a long time. You know, when you're considering like privacy, you have to, considering data, right? So, uh, uh, yeah, that's yeah. We think about it, and the result is that we have some strategy in terms of this side. Yeah, I can explain you. So first of all, so we all know that there's very few data in blockchain, right? It's only balance transactions. And sometimes people don't care about that, don't care about the privacy of that. I don't care. I transfer like $10 to you, maybe. I don't care about that. It's just $10. So, and that's the main reason that it's very hard for now to build a pure, on-chain Web3 applications with privacy because there's not much need for that because there's no much data on chain. I don't need to protect this data using very very heavy technology because it's always there's always cost. I have to pay more. So, okay, when we think about this, we are thinking about when should we use FHE or this PET stuff to protect the privacy and the data on chain. So, okay, we found that the first step is that we need to bring more data to Web3, and then we have a chance to protect the privacy of data in Web3. So that's always the reason of mass adoption of data applications in blockchain. So that's all that results the now strategy of Primus is that's why we are now more focusing on ZKTLS to promote the product. This is because we are using ZKTLS to bring more data in a privacy preserving way. We actually have some very nice ideas, or actually implemented to transfer the DLS content to FHE content with cryptography. So we actually have this connection. But when we are doing a product, when we're going to go to the market, so the first step is that, okay, we want more users to build more data-driven applications, to bring more data from Web 2 to Web 3. At that time, I think we have to use FHE. And at that time, we have to use FHE to do more complicated or more diverse applications, especially related to privacy. This is the future, and this is the correct way to go. So that's the reason we do not go directly to on-chain, privacy preserving applications. We started with like bring data, and then we do on-chain application with privacy data. So we actually spend like half a year to think about it. And the result, is we need to do the first step, and then we do FHE. That's the reason.
Yeah. I actually agree, and thanks for the this detailed explanation. Now I have the easiest question. I'm asking this question at the end of every episode. Would you like to recommend a book that you love the most to our listeners? It could be about cryptography. It could be about anything else. It could be a novel. Just a book recommendation.
Oh, yeah. Actually, I personally, but as a cryptography nerd, I personally love the thesis of Craig Gentry. I spent like 1 month to read it, but it's quite good. But yeah, it's not a good book for for the audience. I know that. So let me think. Yeah, I do have some paper or some book, but it's not related to FHE. It's actually related to MPC stuff. But I think that is very good, and especially you want to know the backend, the background of cryptography and how to implement it. I think this is very important. Is that the programmable MPC book? Maybe I forgot about it. It's maybe something like programmable MPC. It introduces different MPC or cryptography stuff, and it introduces you how to implement it, and introduces you a lot of libraries there. So we need more like cryptography engineers in this area, not just the researchers. So I highly recommend that people who are interested in cryptography to take that book as a starting point and do some coding. And this is quite important in this area. We need more cryptography engineers, and it's very good.
Yeah, thank you. It was a really nice one. I will definitely take a look at it. I mean, I didn't know it, so yeah, it will be also useful for me too. So yeah, thank you so much once again for being with me today. It was a really nice talk, and I mean, I cannot believe it, how fast, how fast it lasted, more than 30 minutes. So it was a really nice opportunity for me as well to know more about Primus, and I hope to see you once again in one of the events, or maybe in another episode of FAT on Chain podcast. So yeah, once again, thank you so much. And if you have any final words, I would love to hear.
Yeah. Actually, yeah. Thank you so much, and I really enjoyed it, and I actually really enjoyed to talk about technology. Yeah, it's kind of the fun of cryptography nerd such as me, and I'm happy to talk with you about more maybe non-tech stuffs and the product and the community and the industry. So yeah, thank you so much for having me here, and probably we can meet next time.
Yeah, thank you. Okay, yeah, today I had Xiang from Premise, and we had talked about many things, including Premise, FHE, verifiable FHE, ZKTLS, confidential compute, and many things more. I hope I hope it was fun and instructive for everybody watching us. Thank you.
Thank you.